Your Power Automate emails aren't clever automations. They're an HR breach waiting to happen. You glued a flow to a service account, crossed your fingers through MFA prompts, and called it done. That's amateur hour. Here's the fix. Microsoft Graph with an app registration, locked by application access policies, so the app can only send from the mailboxes you approve. I'll give you the exact PowerShell, the Graph endpoints, and a custom connector schema. HR notifications, offers, policy updates, terminations will deliver reliably under conditional access, MFA, and tenant restrictions. There's one misstep that silently exposes every mailbox. We'll close it. Foundation, why service accounts, sabotage email flows. Let's start with the myth. A service account is simple. The truth? Delegated auth tied to a human-style identity is fragile by design. Conditional access changes, MFA challenges, and password expiry aren't edge cases, they're routine. Your flow can't approve a push notification at 2:14 a.m., so it chokes, retries, and occasionally sprays duplicates like a malfunctioning label maker. You wanted reliability. You built roulette. Now the overprivilege problem. To make it work, someone grants the service account sent as on a mailbox. Then another exception. Then temporary access to a shared mailbox that mysteriously never gets removed. That creep turns a single-purpose sender into a tenant-wide impersonation machine. HR messages must be pristine. Who sent what, when, and as whom. With shared passwords and mailbox rights, attribution blurs. Was it the flow, the admin, the intern with the cached Outlook profile? Your audit trail is vibes. Audit blindness is more than annoying. It's non-compliant. When an offer letter goes out at 2:14 a.m., you need a clean line to the non-human identity that issued the call, plus the policy that allowed it. Delegated tokens issued to a user account don't give you that clarity. And when tenant restrictions evolve, as they do, delegated flows inherit breakage silently. You discover the blast crater later when managers ask why nobody received policy updates on time. Reliability takes a beating too. Delegated tokens are short-lived and coupled to interactive behavior. Flows wake up, find the token expired, and either fail hard or bounce between retries until they duplicate sends. The help desk gets a ticket. Governance gets blamed. Everyone mutters about Power Automate being flaky when the problem is your auth model. And let's talk compliance. Email isn't a casual transport layer, it's regulated infrastructure. HR notices, policy acknowledgements, and termination communications often sit inside legal and audit requirements. Just make it send is not a strategy. It's negligence with HTML. Now, you might be thinking, but our conditional access exempts the service account. Congratulations, you've bypassed the controls that protect your tenant. You reduced friction by removing the seatbelt. Also, exemptions drift. A well-meaning change to a CA policy breaks your exception or worse, broadens it. You don't discover it until the flow faceplants or starts sending from the wrong identity because someone fixed it at the mailbox level. Everything changes when you stop pretending a robot is a person. Applications need non-human identities with machine-grade auth, certificates or client secrets, and permissions that are precise, inspectable, and revocable without touching user mailboxes. Enter app registrations. You grant mail sent at the application scope, no delegated nonsense, and then you fence that power with application access policies so the app can send as only the mailboxes you explicitly allow. Not helpfully all, precisely the ones you choose. This is where attribution and audit finally make sense. Graph sign-in logs tie calls to the app. Exchange and Purview trails show the mailbox, the operation, the time. You can export diagnostics to log analytics or your CM, correlate by client request ID and request ID, and answer the one question audits always ask: who did what, using which identity under which policy? And reliability? Tokens are obtained via client credentials. No MFA prompts, no browser pop-ups, no passwords expiring at midnight on quarter end. Access tokens live for about an hour, which is predictable. Your flow requests a new one, sends the mail, captures headers, moves on. No drama, no duplicate storm. So here's the foundation. Service accounts sabotage your flows because they conflate human authentication with machine tasks, invite overprivilege, erase attribution, and collapse the second conditional access evolves. You don't fix that with another exception. You fix it by giving the machine its own identity and a fence it can't climb. Architecture app registration plus graph is the professional standard. Enter app registration. Not a person in a trench coat pretending to be a robot, but an actual non-human identity with its own credentials and permissions. It authenticates with client credentials, certificate, or secret, so there's no MFA bingo, no password roulette. It's predictable, and predictability is the oxygen of automation. You start with least privilege. And yes, average user, that phrase has meaning. Grant the app the mail. Send application permission. Application, not delegated. Delegated means act as a user. Application means act as itself, which is exactly what your flow is itself. Nothing more, nothing less. Now, mail. Send at application scope is powerful. Too powerful if you leave it hanging open. The truth? Without a fence, the app can technically send as any mailbox. That's not a feature, that's an attack surface. So we add the fence, application access policies in Exchange Online. These policies tell Exchange even though the app holds mail, Send, it can only act for these mailboxes. Think digital keycard program to open only the HR mailboxes, not the CEOs, not the cafeteria newsletter. Precision. The pattern is simple. Create a mail-enabled security group, call it HR transactional senders if you must be literal. Add only the mailboxes that represent your HR communications. Offers at, policy at, terminations at. Then bind your app registration to that group using an application access policy. Exchange becomes the bouncer. The app shows its ID, Exchange checks the list. If the mailbox isn't in the group, 403. Door stays closed. No drama, just enforcement. Token acquisition uses the client credentials flow. The access token lives for roughly an hour, long enough to do useful work, short enough to limit blast radius. Your flow requests a token, calls graph, and moves on. No pop-ups, no approve sign-in on someone's phone at midnight, because repeat after me, it's not a person. Auditability gets an upgrade. With graph, the sign-in logs tie activity to the app's service principle. Exchange audit shows, send as with the target mailbox. Purview holds the compliance breadcrumbs. You include a client request ID header on every call. Graph returns a request ID and date. Those three values are your tracing trinity. When someone asks who sent that offer, you answer with a GUID and a timestamp instead of a shrug. Compare that to your current mess. Ambiguous shared accounts, fuzzy send days permissions, and email headers that read like a crime novel written by committee. With app registration plus policy scoping, attribution is machine clean. You can export Entra sign-ins, directory audit, and Exchange logs to log analytics or your SIEM, set alerts for anomalies, and actually see patterns instead of guessing them. And yes, conditional access, here's the important bit. Client credentials flows aren't subject to user MFA. That's not a loophole, it's the design. You enforce safety at the permission layer and the policy fence, not with interactive challenges. Tenant restrictions, they still matter, for example, blocking legacy auth or constraining app types, but your app's path is explicit and documentable. You don't need a special carve-out for a fake user account. You need the right app permissions and the Exchange access policy. That's governance, not vibes. Reliability steps forward, too. Because the app identity doesn't expire its password like a bored human. You're not scheduling a quarterly who broke the flow investigation. Certificates can be rotated on schedules. Secrets can be stored in a vault and rolled with change control. The flow keeps running because the contract is clear. App proves itself. Exchange enforces scope. Graph delivers the payload. HR use case mapping becomes straightforward. The security group is your ring fence. Need to add a new sender for onboarding season? Add the mailbox to the group. Need to revoke after a campaign? Remove it. No repermissioning the app. No editing 10 flows. The boundary lives where it belongs. In Exchange's policy, visible, auditable, and testable. Essentially, this architecture separates concerns cleanly. Identity, app registration, capability, mail, send at application scope. Guardrail, application access policy restricting target mailboxes. Transport, Microsoft Graph. Telemetry, Entra, Exchange, Purview, all stitched with request IDs. It's boring in the best way, like a well-run airport. Planes land, planes take off, nobody argues with the runway lights. This is the professional standard. Not because it's trendy, but because it's resilient, inspectable, and reversible. You can prove who can send, who did send, and who can't with a configuration diff instead of folklore. If you insist on service accounts, you're announcing to your future self that you prefer outages with side effects. Use an app, fence it, log it, then sleep. Implementation Part 1. Lockdown sending with application access policies. Okay, so here's the build. We're giving the machine an identity, and we're fencing it so it can only send from HR-approved mailboxes. Precision first, convenience later. Step 1. Create the app and grant the right permission. In Microsoft Entra, register a new application. Call it HR Transactional Mail if names help you think straight. Capture the application client ID and directory tenant ID. Add a client credential, ideally an X. 509 certificate, fine, a secret if you must, stored in a vault and rotated like a grown-up. Under API permissions, add Microsoft Graph, application permissions, mail. Send, then grant admin consent, not delegated. Application, because the app is sending as itself under policy, not borrowing a human. Step 2, create the ring fence. In Exchange Online, you need a mail-enabled security group that represents allowed senders. Name it HR Transactional Senders. Add only the mailboxes you want the app to act for. Offers at Contoso.com. Policy at Contoso.com. Terminations at Contoso.com. Yes, just those. Not everyone for convenience. That's how incidents are manufactured. Step 3. Bind the app to the fence with an application access policy. This is the perimeter. Fire up Exchange Online PowerShell. You'll need the app's service principal ID. That's the enterprise application object in Entra. Then new application access policy. App ID, policy scope group ID, HR transactional senders at Contoso.com. Access right, restrict access, description, HR send scope. That single command is the difference between mail, send can impersonate the tenant, and mail, send can only send as these mailboxes. Exchange is now the bouncer. The app shows its badge, Exchange checks the list, you verify the policy with test application access policy. Example, test application access policy, app identity offers at contoso, expect access check, result, granted. Then try a mailbox, not in the group, test application access policy, app identity CEO at contoso, expect access check, result, denied. If you see granted where you shouldn't, you did something wrong. Fix it before congratulating yourself. Now, align with conditional access and MFA expectations. Client credentials aren't interactive. CA policies targeting user sign-in controls and MFA prompts don't apply to an app asserting its own identity. That's not a gap, that's the model. Document it. Your tenant restrictions still matter. Block legacy protocols, restrict app consent to admins, require certificates for confidential clients if you're serious. The key is you're not creating risky user exceptions. You're using an app with least privilege and an Exchange fence. Let's talk PowerShell prerequisites so you don't trip. Use the Exchange Online Management module. Connect Exchange Online with an account that can manage application access policies. Ensure the group is mail-enabled and resolvable by primary SMTP address in policy scope group ID. And yes, the appit in the policy can be the application client ID. Exchange figures out the service principal. If you've duplicated objects across directories, that's on you. Keep environments clean. Graph tracing is not optional. Every send request should include a client request ID header, a guide you generate. Graph will echo back request ID and date. In your flows, capture both response headers and store them in your error log. Request ID, client request ID, date, sender, recipient's outcome. When an HR manager says, "Did the offer go?" you don't guess. You search by GUID, reconcile with Entra sign-ins and Exchange Audit, and answer with receipts. Now test the perimeter with real calls. Acquire a token via client credentials for https://graph, microsoft.com, default. Attempt post v1, users offers at contoso.com, send mail with a minimal payload. It should work. Attempt the same call with CEO at contoso.com. You should get 403 with an error code like error access denied or authorization request denied. That's the policy doing its job. If you see 401, your token is wrong. If you see 403 on an allowed mailbox, your policy scope or group membership is wrong, or you forgot admin consent. This isn't magic, it's plumbing. Check each joint. Document tenant alignment decisions. Write down that CA/MFA don't gate client credentials. That risk is mitigated by mail. Send at application scope plus an application access policy restricting target mailboxes. Note secret or certificate storage, key vault, rotation cadence, and who can modify the policy. If governance can't read it, it didn't happen. A quick micro story to keep you honest. Last week, a team asked why their HR flow randomly failed. The service account password expired. When they rushed to fix it, someone gave it send A's on a shared mailbox used for newsletters. Within hours, automated HR mail and marketing mail blended. Audit was a mess. We shifted them to an app, added mail. Send, created the HR transactional senders group, bound the policy, and, spoiler, traceability returned. That's the power of the fence. Finally, regression proofing. After you create or change the policy, run test application access policy for each HR mailbox in scope and a few out of scope. Bake those tests into a runbook. On secret or certificate rotation day, validate token acquisition, then run policy tests, then send a deliberate test mail with a unique header, X-trace intent, HR policy check, so you can find it in headers and logs. If you think this is overkill, you've never explained a breach to legal. Perimeter set, app identity in place, Exchange enforcing scope. Next, we wire the actual send over graph, clean payloads, clean retries, no connectors yet. Implementation part 2, graph email, send patterns and endpoints. Now we orchestrate the actual send. No connectors, no mystery, just HTTP against graph with headers you control. Core endpoint first, post https://graph, microsoft.com where you want users or sender UPN, send mail. Replace sender UPN with the allowed mailbox, like offers at contoso. This endpoint senses that mailbox, which is exactly why the application access policy matters. Your body is a JSON envelope called message plus a save to send items flag. The minimal payload looks like this, conceptually not code theater, message, subject message, body with content, type HTML or text and content message. To recipients as an array of objects with email address. Add CC recipients and BCC recipients arrays when needed. Save to send items, true for HR, so send items shows a record. False only if you've planned an alternate archive. Attachments come in 2 flavors. For most HR scenarios, offer letters, policy PDFs, use JSON attachments with content bytes as base64. Each item has name, content type, and content bytes. Keep individual attachments sane. Graph is happy, but your recipient's gateways are not. If you need full MIME control, custom headers, S-MIME payloads, exact line endings, you pivot to send mail with a MIME message in base64 via the me send mail equivalent for app as user scenarios, or you use users POSH ID messages with create plus send. For 99% of HR automation, the JSON model is simpler and safer. Headers matter. Always include client request ID as a guide you generate per call, and prefer Outlook. Time zone if you care about date normalization on drafts, though for send mail it's less relevant. Capture response headers, request ID and date. These are your correlation anchors across Graph, Entra sign-ins, and Exchange Audit. Now the unpleasant but necessary part, rate limiting. When Graph returns 429, it's not a suggestion, it's a command. Respect retry after in seconds. Implement exponential backoff that starts with retry after if present, otherwise a sane default 248 seconds with jitter. Idempotency is your shield against duplicate HR emails. Generate a stable idempotency key per intended outbound message. Compose it from the business object ID plus recipient and a timestamp bucket, and store it. If a retry happens, check whether you've already recorded a successful send for that key before you fire again. You're preventing the 2 offers, 1 candidate embarrassment. Error classes are predictable. 401 means your token is missing or expired. Acquire a new access token using client credentials and replay once. 403 is policy or permission. Decode the error.code in the JSON. Authorization request denied or error access denied usually means your mailbox isn't in the application access policy group or admin consent didn't happen. Do not retry a 403. Fix configuration. 404 on the user path usually means you misspelled the sender UPN. 5x is transient service wobble. Retry with backoff over a new HTTP connection. Your flow should treat 429 and 5xx as recoverable within a small window. Everything else escalates. Security hygiene. Do not log bodies with PII. Yes, average user. This includes the entire offer letter. Log metadata. Client request ID, date, sender, recipient count, attachment count, outcome, and any error. Code plus a redacted message. If you must keep a copy of the sent content, rely on the mailbox's sent items or a governed archive, not your flow logs. S-MIME. If your HR notices require signing or encryption, you're in MIME land. You'll build the full MIME payload with the appropriate content type and transfer encode it as base 64 within the raw message. Application permissions can still send. The complexity lives in building the MIME correctly and managing certificates. For most internal policy updates, TLS at transport plus DKIM/DMARC alignment is sufficient. Save as MIME for regulated cases where a signature is mandated. HR payload patterns should be templated, not hand-built per run. Store HTML templates with token placeholders, candidate name, start date, manager name, policy link. Replace at runtime, sanitize inputs and include a lightweight Xtrace header via internet message headers for internal correlation, like Xtrace intent, HR offer, X business id, 1, 2, 3, 4, 5. Keep custom headers minimal. Some gateways strip or rewrite them. That's fine. You locked the IDs already. Idempotency deserves one more line. Use a stable deterministic key and record success before you acknowledge completion to upstream systems. If a retry loop kicks in, your first step is to query your log for that key. If found and success, abort send. If found and failed with a final code, surface the error. If not found, proceed. Finally, build for burst without tripping limits, queue outbound messages and process in controlled concurrency. 2 to 4 parallel sends per mailbox is sensible. Respect retry after globally. When you get throttled, slow the entire worker, not just one thread. Your goal isn't maximum throughput, it's guaranteed delivery without collateral damage. We've now turned send an email into a disciplined API call, scoped identity, clean payloads, predictable retries, and zero drama. Next, we wrap it in a Power Automate custom connector so every flow gets the same guardrails without reinventing anything. The implementation part 3, Power Automate custom connector schema. Now we make this repeatable. A custom connector turns careful HTTP into a single governed action your flows can reuse without copy-pasting headers and retry logic like a teenager's homework. Start with basics. Base URL is https://graph, microsoft.com, security is OAuth 2 with client credentials. No user delegation, no interactive login. Define the token URL as your tenant's Microsoft identity endpoint and the scope as adds default, which instructs Graph to honor the app's granted application permissions, including mail. Send. Store the client secret or certificate reference in a secure connection parameter, ideally tied to an Azure Key Vault-backed connection, so creators can't exfiltrate credentials by helpfully previewing settings. Define one action. Send mail. Method, post. Path, v1, users must sender, send mail. Create a required path parameter called sender, validated as an email address. Yes, validated. If the sender isn't in your application access policy group, the call will 403 and your error object will explain why. Don't guess. Let Exchange be the bouncer. Request schema should mirror Graph's JSON. At minimum, subject, string, body, object with content type and content, to recipients, array of email addresses with optional CC recipients and BCC recipients arrays. Add attachments as an array of objects with name, content type, and content bytes, base 64. Include a Boolean save to send items defaulting to true for HR. Add optional internet message headers as an array for lightweight tracing. Name and value pairs, X trace intent, X business ID. Keep it small. Mail gateways have opinions. Security headers and correlation belong in the connector, not scattered in flows. Define a static header parameter, client request ID, that generates a guide per call when omitted, but allow override for advanced scenarios. Always return response headers, request ID and date. Expose them as outputs so flows can log them without spelunking into raw response metadata. Now error handling. Standardize it. Define a normalized error object with fields. Status, int, code, string, message, string, request id, string, date, string, and retry after, int. When graph returns 429, pass retry after and surface it. For 5xx, surface a retriable flag. For 401, return a clear acquire token failed code. For 403, policy denied with a message that explicitly says sender not authorized by application access policy or permission missing. Save the detective work for actual mysteries. Connector policies matter. Throttling. Implement exponential backoff with jitter inside the connector for 429 and 5x up to a safe cap, say 3 attempts. Respect retry after first. Timeouts. Set a sensible HTTP timeout, e.g. 60 seconds, and allow the flow to configure a higher ceiling for large attachments. Concurrency. If your platform supports it, limit parallel calls per connection to avoid tripping tenant throttles. You're designing for steady throughput, not chaos. Outputs should be boring and useful. Return status request ID, date, client request ID, and a summary object. Recipients count, attachments count, save to send items. If you want to be generous, echo the sender and the first to recipient for quick eyeballing in run history. Do not echo the entire body content. You're building traceability, not a leak. In Power Automate flows, wrap the action in a scope named try. Follow with a scope named catch, configured to run on failure. In try, call sendmail. In catch, use results try to extract the connector's error object and log to a governed store, Dataverse or SharePoint, capturing client request, id, request ID, date, sender, recipients, status, code, and message. Then branch. If code is policy denied, alert the admin owning application access policies. If code is acquired token failed, trigger a credential runbook. If retry after exists, requeue or delay intelligently. Add a small guardrail. Before sending, validate sender against a maintained list mirrored from the HR transactional senders group. It's a fast fail that saves a round trip and keeps noise out of your logs. And yes, use the safe navigation operator, the question mark, in expressions when accessing optional outputs so a missing header never crashes your flow. What you get is a single action that encodes the rules. App auth, scoped sender, durable retries, clean errors, and first-class traceability. Congratulations, you've replaced folklore with an interface. Audit, monitoring, and incident prevention. You've secured delivery. Now prove it. Security that can't be measured is superstition in a hoodie. Start with audit sources that actually matter. Entra sign-ins for the app's service principal tell you when tokens were minted and from where. Directory audit logs record permission changes, who granted mail, sent, who consented, who touched the enterprise application. Exchange audit logs tell you the mailbox operations. Send ACE, send on behalf, mailbox access. Purview holds the compliance trail. Route all 3 into log analytics or your CM via diagnostic settings so you don't play download CSV forensics after an incident. Centralize or enjoy chaos. Your choice. Tie it together with correlation. Remember the tracing trinity, client request ID you generate, plus request ID and date from graph. Those IDs show up across systems. When an HR leader asks, did policy updates go to 8,000 employees at 9 a.m., you pivot to your structured log store, a Dataverse table, or a SharePoint list if you're frugal, and query by client request ID. The entry links to Entra sign-ins, points to Exchange Audit for the mailbox, and carries the graph request ID for cross-checking. Mystery solved. No seance required. Diagnostic settings aren't a suggestion. Turn them on for Microsoft Graph sign-ins and directory audits via Entra's diagnostic export. Exchange admin and mailbox audit logs. Purview audit events if your compliance team expects attestations. Send them to log analytics with a retention that matches your regulatory window. Yes, 90 days is not enough if you answer to audits with multi-year lookback. Storage is cheaper than litigation. Your operational logs need structure. In your flows catch block, write a single record with fields that future you will actually use. Client request ID, date, sender, recipients count, attachments count, status, error code, redacted message, retry after seconds. Add intent tags, offer, policy update, termination, so you can pivot during incidents. Put a partition key on the business object ID if you ever want to answer show me everything tied to candidate 12345 without scanning the galaxy. Alerting is not email the admin when anything fails. That's how inboxes die. Build focused signals. Failure rate threshold. Alert when more than X% of sends fail in 10 minutes. Throttling spike. Alert on clusters of 4 to 29 with retry after above a threshold. Your flow is outrunning your tenant's patience. Policy denied detection. Alert immediately. Someone tried to send from a mailbox outside the application access policy scope. That's either misconfiguration or an attempted escalation. Anomalous volume. Detect HR blast patterns at odd hours or unusual recipient domains. Correlate with TERL and outbound spam policies so you don't trip compliance landmines. Yes, tenant restrictions and outbound policies still apply. The external recipient rate limits and bulk sender authentication requirements exist to protect you and everyone else. Respect them. Set dashboards for daily external recipient counts and SBF a DKIM DMARC alignment, or enjoy bizarre deliverability issues you'll blame on Graph. Now the runbook, the thing you wish you had during the incident you deny will happen. Include, revoke and rotate, immediate steps to disable the app's client secret or certificate with Key Vault integration and who's authorized to do it. Policy lockdown, how to disable the application access policy temporarily, or better, how to tighten the scope by removing mailboxes from the HR transactional senders group. Validation tests, exact test application access policy commands to confirm state before and after changes. Regression suite, token acquisition test, a controlled send to a test mailbox with X-trace intent, HR policy check and verification steps in Exchange audit and log analytics. Rollback, how to restore prior config from documented diffs, not memory. Close the loop we planted earlier. The one misstep that silently exposes every mailbox is skipping the application access policy because mail, send is already least privilege. It isn't. Without the policy, your app can impersonate the tenant's entire directory. The fence is what prevents lateral blast radius. It also gives you a crisp error, 403 policy denied, when someone wanders outside the lane. Incidents become containable by design. Last piece, ownership. Assign a human owner for the app, the policy, and the connector. Document contact methods in the enterprise applications directory metadata. When the alert fires at 2:14 a.m., the on-call engineer shouldn't be spelunking SharePoint to find a name. Efficiency is not an accident, it's documentation plus accountability. You've now moved from, I hope it works, to, I can prove it, detect drift, and recover fast. That's incident prevention, not incident theater. Here's the point. Stop impersonating people with brittle service accounts. Use an app registration with mail, send, fence it with an application access policy, send through Graph, and log like an adult. If this saved you from another midnight outage, subscribe. Next, grab the exact PowerShell, Graph payload schemas, and the custom connector definition. I'm walking through each command and endpoint in the follow-up. Implement it before your next HR cycle so your offer sent means delivered, auditable, and scoped. Entropy wins by default. Choose structure.